Exponents and power. This is our chapter of class 8. Today we are going to deal with this particular chapter. Earlier in the class 7 we have already discussed some things about it, and our objective for this class are power with negative exponent, laws of exponents, and use of exponents to express small numbers in standard forms, also comparing very large and small numbers. For that we have to understand what are the powers. Powers are 7 to the power 3 means 3 factors of 7. 7 raised, we say it 7 raised to 3, 7 raised to 3, which is base. Here base is 7 and raised to 3, so 3 is exponent and 7 raised to 3 is called power. What does it mean 7 raised to 3? 7 raised to 3 means 3 factors of 7. In a very generalized way, we can say that is exponential form. Exponential form, the exponent of a power indicates how many times the base multiplies itself. For example, x raised to n, it means that n factors of x. For example, 7 raised to 3, it means 7 multiplies to 7 multiplies to 7, that is 7 multiplies itself 3 times. For in a generalized way we can write 2 raised to m, that is 2 multiplies to 2 m number of times. So now we have another very important thing, that is negative law of exponent. This is very useful, and if the base, what is that? If the base is powered by the negative exponent, then the base becomes reciprocal with the positive exponent. For any non-zero integer x, x raised to negative n is equal to 1 upon x raised to n. That can easily be understood by this particular example. For example, 5 raised to negative 3, it means 1 upon 5 raised to positive 3. 1 raised to positive 3, which we have say that if the base is powered by the negative exponent, here it is negative n, then the base becomes reciprocal with the positive exponent. So easily we can calculate 5 raised to negative 3 is equal to 1 upon 5 raised to positive 3, that is 1 upon 125. From that very concept we get that x raised to negative n is the multiplicative inverse of x raised to n. It means that when we multiply x raised to negative n with x raised to positive n, we will get 1 as the product. From this very concept we can expand a number of decimal form in exponential way. Write this 1425.36, it is the expanded in the exponential form, and that is in front of all of you. So now again the laws of exponent, multiplying powers. It is very useful when we multiply some powers with the same base and different exponent. What we get? We get the same base and add the exponent. For example, x raised to m multiplied to x raised to n, and so we have to keep the base same, that is x, and we have to add the exponents of both the powers. The example is very evident, that 2 raised to 2 into 2 raised to 3 is equal to 2 raised to 2 plus 3, that is 2 raised to 5. In that continuation laws of exponent, we have dividing powers. When dividing powers with the same base, keep the base will be the same, and subtract the exponent, and exponent will be subtracted. Here x raised to m divided by x raised to n. So we will keep the base same, that is x, and we will divide the exponent, that is m minus n. Here 5 raised to 7 divided by 5 raised to 4, and we get 5 raised to 7 minus 4 is equal to 5 raised to 3, that is 125. In the laws of exponent, then comes power of a power. What is that? If you are raising a power to an exponent, you multiply the exponent. Here power is x raised to m, and that is also raised to up to n. So we will multiply the exponent, that is x raised to m n. Here it is 5 raised to 2 up raised to 3, that is 5 raised to 6. So now it is product law of exponent. If the product of the bases is powered by the same exponent, then the result is a multiplication of individual factors of the product, each powered by the given exponent. Here it is x, the product of x by raised to n is equal to the product of x raised to n on x y raised to n, that is ab square is equal to product of a square and b square. So now next law is quotient law of exponent. If the quotient of the bases is powered by the same exponent, then the result is both numerator and denominator, each powered by the given exponent. Here the quotient xy is raised to the exponent m, then we get the numerator x raised to exponent m upon denominator y raised to exponent m, that is 3 by 4 raised to 3 is equal to 27 upon 64. So that this is very important and generalized form, zero law of exponent. Any base powered by 0 exponent x equals 1. Any base powered by 0 exponent equals 1. What does it mean? It's mean that whatever numbers you come, but you raise it to 0 power, you will get finally 1 as a result. So our next concept is use of exponent to express large and small numbers in standard form. In our earlier classes we have seen lots of large number which has been expressed in exponential form, but in this class we will see lots of small numbers. For example, size of a plant cell, size of a electron, weight of electron, and this is a very large number but very small, a small number but in a big expanded form. So we can use that exponential form to express this concept. For example, if the point is 0.000125 meter, we have to express, we will write it as 1.275 into 10 raised to 7. For some example, here it is example, sorry, for example 1.5 into 10 to the power 11. Here we see where there are how many zeros are there, 1 2 3 4 5 6 7 8 9 10. So many zeros. We can express this as 1.5 into 10 raised to the power 10 raised to 11. Likewise, 0.0000007, we can express this as 7 into 10 raised to the power negative 6. So now we are at the end of our topic and this particular chapter. So there are some resources available at the end of this chapter. You may consult and get benefit out of it. Thank you.